Hello guys and welcome back to my YouTube channel. So today we will deal with magical probability. Definition: probability of a single event occurring without considering other event. Example: if we have a joint probability distribution for variable x and y, the marginal probability px represents the probability distribution of alone by summing or integrating over all possible values of y. Conditional probability. Conditional definition: probability of event when any other event has already occurred. Example: given that it is already raining event A, the conditional probability converts the probability of observing heavy traffic. It quantifies how the probability of event B changes when we have additional information about event. Our next topic is probability distribution. Mathematical representation of likelihood of different outcomes in a random experiment or variable. Example: probability distribution provides a framework for modeling and analyzing data, making predictions and estimating another unknown parameters. Common probability distribution include the normal distribution and the binomial distribution. By assigning probability definition, statistical framework that builds or assigns probability based on prior knowledge and known as evidence. Example: Bayesian probability allow us to incorporate prior information and revise probability as new data become available. It is useful when we have limited data or prior knowledge that can influence the analysis. To analyze these concepts statistically, let's consider the example. Suppose we want to analyze the relationship between the study horse x and y. The same example that we have see upper. An example for y of the group students. We have calculated the we can collect data on the number of hours each student studies and their corresponding exam score. By calculating the joint probability distribution of x and y, we can understand the likelihood of specific combinations of study hours and exam score. So here is a example of joint probability. Import numpy as np x and np dot random 1 to 7 rand int. It can take random numbers starting from 1 and end at 0 and the size is 100. And y np dot random choice h and t coin toss outcome. So joint probability is np dot sum. This is a equation of sum. X is equal to s is double is equal to 6 and y double is equal to h and divided by length of h. So the joint probability will be defined. Magical probability. This is similar as magical probability, but the difference is that formula: magical probability, number of bin counts in X, and the length of X. This is a formula to find the magical probability. Here you can see X is equal to 1, 0, X is equal to 2 is equal to 0.2, X is equal to 3 is equal to 0.22. This is a marginal probability of X. So now let's see a conditional probability. In conditional probability, we can take random numbers, and conditional probability, the formula of conditional probability is number np dot sum y into X is equal to 4 double is equal to H, and np dot sum X is equal to 4. Conditional probability of y is equal to H and X is equal to 4 will be this one, 0.57. This is also probability distribution. So now these are the additional attributes and methods of NumPy array. Let's see in detail. Reshapes the array into a new shape specified by new shape. It returns a new array with a modified shape without changing the original array. Max is equal to return the maximum value in the array. Min return the minimum value in the array. Argmax return the index of the maximum value in the array. Argmin return the index of minimum value in the array. Shape return the tuple representation and the shape of the array. Dtype return the data type of the array. Size return the total number of elements in the array, and dim return the number of dimensions in the array. Here are some examples that determine the attribute methods. Create array. ARR is equal to np dot array. This is a formula. Reshape the array into 2D array with 2 rows and 3 columns. Okay, let's have a practice of this code. Let's see. Let's create an array. ARR is equal to np dot series. np dot array. 1, 2, 3, 6, 7, 9, 11. Now let's find the shape of array. Print Okay, that's fine. Now we will change the shape. Change the SHAP shape of array. New shape is equal to print the new shape six. One, two, three, four, five, six. So now here you can see that our shape will be changed. Our shape will be you can see that our shape will be changed. And now if we want to find the maximum value in array, so find the max value in array. Okay, so now find the max value in the array. To find this max value is equal to ARR dot MA max into ARR. Print max value. So in this array the max value will be 9. Now let's print the minimum value. Find the minimum value. Value is equal to ARR dot min minimum print min val. So the minimum value will be 1. So our next will be find the maximum index. Find the index of maximum value in the array. Max index array dot the attribute that will be used is ARR dot arg max. Max index will be ARR dot arg max print So the max index, the index of maximum value will be 5. Let's we count 0, 1, 2, 3, 4 and 5. The fifth index has maximum value. As it is, we will find the minimum index value. Find the index with minimum value. Min index is equal to array dot min min print so the minimum value has index 0. The 1 has an index 0, so it can print 0. So now maximum index, minimum index, and so now let's find the array data type. Array data type is equal to a dollar dot d type print int 32. Array dot d type so now let's find the size of array by using a dot size. Find the size is equal to a dot size at the size print size. The size of array will be 9. Let's count 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 9 elements in array, so it can print 9. So now we will print the dimensions, total dimensions in array. Find the dimensions in array. Is equal to a dot and dim print dimensions. So the dimension of array is 1. So now our next topic will be copying array. When working with the array, it's important to understand how copying work. In Python, variables are reference to object. So assigning an array to a new variable does not create a copy, but rather create a new reference to same array. To create the copy of an array, you can use the copy method or the array.copy syntax. Appending elements. To add element to any existing array, you can use the append method. it appends the element at the end of the array and return a new array with the added element. Note that this option create a new array and does not modify the original array in place. So now our next method is inserting element. The insert method allow you to insert a element at the specified position in an array. It take two arguments, the index at which the element should be inserted and the value of element similar to the append. The insert method return a new array with the inserted element. Storing array. NumPy provide the sort method to sort the element of an array in ascending order by difficult in it. Perform an in-space sort method order modified to original array. If you want to create a new stored array without modifying the original array, you can use the numpy.sort function. To remove element from an array, you can use the delete function. Delete function is a very common function. This will be used in a list, also used in a list tuples. It take the array and the index and the insides of the elements to remove an argument and return the new array with the specified element removed. Similar to other method, delete does not modify the original array. Combining array. There are several ways to combine the NumPy array. Most common method is concatenation, which can be done using the concatenate function. It takes the sequence of array and axes along which the array should concatenate and return the new array. Concatenating is a possible of joining array along the existing array axis. In NumPy array, you can use the concatenate function to create array along a specified axis. It takes a sequence of array and the axis argument and return a new array. Here are some examples that dominate the operation on array. So let's see an example. Here is array 1. Array 1 will be 1, 2, 3, and by using a copy function we can copy the array, and you can see that the array will be print in a simple way. So let's see, and here you can use a append function to append the array. So this is as similar as we see in Python lists.